Hello everyone. In this lecture, we will study how to represent a graph, means a representation of the graphs. There are the many ways to represent a graph. So let's check these methods one by one. There are many useful ways to represent the graphs. Some of the methods like urgency lists, urgency matrices, and incident matrices. Okay, so let's look at these ways or methods one by one. Urgency list. This representation method is mostly useful when information about the vertices is more desirable than information about the edges. Okay, so when it is useful, when information about the vertices is more desirable than the edges. It specifies, means urgency list specifies the vertices that are adjacent to each vertex of the graph. So see here one example. What is the question? Use urgency list to describe the simple graph given in the figure 1. So question is what? Use urgency list to describe the simple graph given in the figure 1. So in the question itself, the figure is given, a simple graph. Okay, so from this graph you have to find out the urgency list. Okay, so in this graph, see here carefully, there are the 5 vertices are there, A, B, C, D and E. So from this graph or from this figure you have to find out the urgency list. So see here the solution. So there is one table and that table contains the 2 columns. Okay, first column is the vertex, so which are given in the graph A, B, C, D, E, and the second column is what? Adjacent vertices, means each and every vertex, what are the adjacent vertices you have to find out. Okay, see here, first row A, vertex A is given, and for that vertex A there are the adjacent vertices are 3 adjacent vertices are there, B, C and E. Let's check here. So see here, A to B, A to C and A to E. Understood? B, C, E. Then second row, B to A. From B there is only one adjacent vertex, A. Then for C, A, D, E. For C, A, then D and E. For D, C and E. For D, C and E. And for E, A, C, D. For E, A, C and D. Understood? This is the adjacent and urgency list for a simple graph that is given in the question. 2 columns, vertex and adjacent vertices you have to find out. And this is one method or one way how to represent a graph. Let's look here another example. Represent the directed graph shown in the figure by listing all the vertices that are the terminal vertices of the edges starting at each vertex of the graph. Okay, in the question the directed graph is given. In the first question simple graph is given, but in the second example a directed graph is given and you have to find out what are the terminal vertices of each and every vertex. Understood? So see here, table 2, that table contains the adjacency list for a directed graph. 2 columns, initial vertex and another column is the terminal vertices. So let's check for the first vertex A. Terminal vertices are B, C, D, E. Check here. For A, B is the terminal, C, D and E. Then for B, B and D. For B, B itself and D. Understood? At the vertex B there is a loop. So this is the terminal, this is initial vertex also and the terminal vertex also, because the loop is present at the vertex B. Then C, A, C, E. For the C itself, then A, then E and C. A, C, E. For D, there is the no terminal vertex for the D, because at the vertex D, all the edges are incoming. No outgoing edges there in the graph. That's why the vertex D doesn't have any terminal vertex. Then next vertex or last vertex E, B, C, D are the terminal vertices. Let's check out for E, B, then C and D. So these are the terminal vertices. Now let's check out the second method to represent a graph. What is that? Adjacency matrices. First one is what? Adjacency list. You have to list all the information about the graph. But the second method is adjacency matrices. To represent the graphs using the adjacency list can be cumbersome or difficult if there are the many edges in the graph. If in the graph that graph contains the many edges or the more edges, then how we can calculate the adjacency list? It can be difficult or it can be cumbersome. Okay, to solve this problem or to simplify this computation, graphs can be represented using the matrices, using the adjacency matrices. Suppose that G is equal to, graph G is equal to V E. Is a simple graph where V stands for the vertices is equal to the n number of the vertices are there. Suppose that the vertices of G are listed arbitrarily as like 1 to up to n. Then adjacency matrix A of G, or we can say that AG, with respect to this listing of the vertices is the n into n 0 1 matrix. Okay, 0 1 matrix with 1 as its ijth entry when I and j are adjacent. So why it is called as that matrix is called as a 0 1 matrix? 0 stands for 1 stands for when there is an edge between I and j, two vertices. Suppose there is a graph G, there are the two vertices are there, I and j. If there is an edge present from I to j, then we can say that the value will be 1. And when it will be 0? When I and j are not connected, means there is no edge present between I and j, then we can say that the value will be definitely 0. That's why this matrix is called as a 0 1 adjacency matrix. Understood? 0 stands for no edge and 1 stands for the edge is present. Next, in other words, if its adjacency matrix is A is equal to Aij, then Aij is equal to 1 if I and j is an edge of j. So as I've already told you, 1 stands for there is an edge present in that graph, and 0 otherwise it means no edge present between I and j. Okay, see here one example. Question is what? Use an adjacency matrix to represent the graph shown in the figure. Okay, see here in this question the simple graph is given A, B, C, D, and you have to represent this graph by using the adjacency matrix. See here, your first task is to solve this problem or order the vertices first as A, B, C, D. Okay, you can choose any names like PQRS. Okay, so I have chosen here A, B, C, D. Okay, and order is A, B, C, D. Then the matrix representing this graph is as below. Okay, so rows and the columns Any into any matrix is here. ABCD and ABCD. ABCD rows and ABCD columns. So see here, first row and the first column, A to A, the value is 0. Why 0? Because from A to A in this graph, there is no edge. See here, from A to B, first row, second column, A to B, the value is 1. Let's check out here. From A to B, definitely there is an edge present. So we can say that the value is 1. From A to C, edge is present there. Yes, A to C. So the value is 1. A to D. See here, A to D, edge is present. The value is 1. Then first row is over. Second row, first column, B to A. The value is 1. B to A. Now see here, this is a simple graph. This is a simple graph and undirected graph also. So in the undirected graph, you can say that there is an edge from A to B and B to A. Both way you can say that from A to B is equal to from B to A. Understood? So from A to B, edge is present, value is 1. And from B to A, edge is present, value is 1. So any way you can say that. That's why in this matrix from B to A, the value is also 1. From B to B, the value is 0. Means second row, second column, value is 0 because there is no loop at the vertex B. B to C, second row, third column, the value is 1. From B to C, there is edge present? Yes. B to D, there is no edge between B to D, that's why the value is 0, obviously. Second row is over. Third row, first column, C to A. Yes, edge is present. C to B. C to B, edge is present. C to C, no loop. C to D, no edge is present. So, similarly, you can check out for the fourth row and the all columns. Understood? Next, see here the example 2. Draw a graph with the adjacency matrix. See here, the question is different. In the first question, you have given the graph and you have to find out the adjacency matrix. But here, in this question, the adjacency matrix is given and you have to find out from that matrix, you have to draw or you have to find out the graph. See here, the adjacency matrix is given. So for your simplicity, you can write down here in the upper ABCD or PQRS, anything you want, and same here ABCD. Okay, so rows, n rows and n columns are there, ABCD. So I have chosen here A, B, C and D. So see here, A to A, no edge is present, so there is no loop. A to B, second row, first row, second column, A to B, edge is present, that's why the value is 1. A to B. A to C, the value is 1, so obviously there is an edge between A to C. So here A to C. A to D, we can't connect A to D because the value is 0 in the adjacency matrix, that's why we can't draw here edge between A to D. Then second row, first column. B to A, obviously B to A, the edge is present. B to B, no loop is there. B to C, no edge because value is 0, so we can't draw here edge. Then B to D, yes, value is 1, so we can draw here B to D edge. Then C to A, C to A, edge is present. C to B, no edge. C to C, no edge. C to D, the value is 1, we can draw here edge. Likewise D to A, 0. D to B, yes. D to C, edge is present, and D to D, 0. Understood? So by using the adjacent matrix, you have to draw a graph or you can draw a graph. There are some points you have to remember because of our earlier discussion. See here, an adjacency matrix of a graph is based on the ordering chosen for the vertices. Definitely, because it is based on the order you have chosen. So here in this example, I have chosen the order what? A, B, C, D. So you can choose any order like B, C, D, A, C, D, B, A. Whatever you want to order, you can choose. But in this question, I have chosen A, B, C, D. So that's why there are the n factorial different adjacency matrices for a graph. Why? Because there are n factorial different orderings of n vertices. So this adjacency matrix of a simple graph is symmetric. Now what is meant by the symmetric? Symmetric means what? Aij is equal to Aji. What is the Aij? Suppose there are the two vertices are there in the graph I and j. Suppose there is edge present between I and j, then definitely the edge present between j and I. Then and then only we can say that graph is a symmetric. Understood? So because both of these entries are 1 when I and j are adjacent and both are 0 otherwise. The one value is present when the I and j edge is present between I and j, and if there is no edge, then you can say that it's 0. A simple graph does not contain any loop. That's why each entry aii where I is equal to 1 up to n is 0. Obviously, if the graph does not contain any loop, the value will be obviously 0. Adjacency matrices can also be used to represent the undirected graphs with the loops and with the multiple edges. A loop at the vertex AI is represented by a 1 at the ith position of the adjacency matrix. Obviously, if the loop is present in the graph, then value will be definitely 1. And if there is no edge, no loop present, then value is 0. When the multiple edges are present, then at that time the adjacency matrix is no longer a 0 1 matrix. See here carefully. When the multiple edges are present, then the adjacency matrix is no longer a 0 1 matrix. Why is it so? Because the ijth entry of this matrix equals the number of the edges that are associated to AI and AJ. So why it is not a 0 1 matrix? Because 0 stands for if there is no edge present between the I and J, and 1 stands for if there is an edge present between the I and J. But if the graph contains the multiple edges, then suppose there are the two vertices I and J, and between that vertices I and J, suppose there are the 3 edges are there. Okay, so value will be definitely 3. And how we can say that it is a 0 1 matrix? Understood? Because in that vertices there are the 3 edges, means multiple edges are present. That's why we can't say that this matrix is 0 1 matrix. Next, all undirected graphs, including the multigraphs and pseudographs, have the symmetric adjacency matrices. Understood? So what is the multigraph? Multigraph means that undirected graph contains the multiple edges but no loops. Okay, and what is meant by the pseudographs? Pseudographs means it is an undirected graph that may contain the multiple edges and also loops. Understood? The slight difference between the multigraphs and the pseudographs. Multigraphs means multiple edges are present but no loops. But in the pseudographs, multiple edges and loops both are present in the pseudographs. Next, see here one example. Use an adjacency matrix to represent the pseudograph shown in figure 5. So see here the figure of the pseudograph. So see here there are the multiple edges are present between the vertices. So by using this graph you have to find out the urgency matrix. So first order the vertices A B C D rows and the columns. So from A to A, see here, A to A there is no loop present, so value is 0. From A to B, see here, there are the three edges are present, upper, down and middle. So the value will be 3. A to C. From A to C, there is no edges present, that's why the value is 0. A to D, there are the two edges are present. A to D, there are two edges present, so value is 2. B to A, again the value is 3. B to B, 0. B to C, there is only one edge is present, so a value is 1. B to D, only one edge is present. C to A, 0. C to B, 1. C to C, 1. C to C, see here, the loop is present at the vertex C, that's why the value is definitely 1. C to D, two edges are present. D to A, again two edges. D to B, 1. D to C, 2 and D to D, no loop is present, that's why the value is 0. Now see here, the urgency matrix can be used to represent a directed graph also. Okay, in the earlier PPT we have seen how we can use this urgency matrix to represent a simple graph, to represent a undirected graph, to represent a pseudo graph, to represent a multigraph. So this urgency matrix can also be used to represent a directed graph. Okay, so in this directed graph, the matrix for a directed graph G is equal to VE has a value 1 in its ijth position if there is an edge from I to J, where 1 to up to n is an arbitrary listing of the vertices of the directed graph. So in other words, we can say that if Aij is the urgency matrix for a directed graph with respect to this listing of the vertices, then Aij is equal to 1 if there is an edge present between I and J. Okay, and if there is no edges present, the value will be definitely 0. Next, the urgency matrix for a directed graph does not have to be symmetric. See here, the urgency matrix for a directed graph does not have to be symmetric. Why? Because there may not be an edge from Aj to Ai when there is an edge from Ai to Aj. Understood? Suppose there are the two vertices are there in the graph I and J. So there is a graph edge from I to J. There is no edge present from J to I. Then how we can say that it is a symmetric? For the symmetric, the condition is what? The condition is that from I to J edge is present, then J to I there is also must be present that edge. Then only we can say that two vertices are the symmetric. Understood? Okay. So this urgency matrix for a directed graph does not have to be symmetric. Urgency matrices can also be used to represent the directed multigraphs also. So such matrices are not 0-1 matrices because there are the multiple in the same direction connecting the two vertices. Obviously, suppose that the two vertices are there and there are the three edges are there. Among these three edges, suppose two are directing to A to B and one is directed from B to A. Then how we can say that it is a 0-1? Okay, so value are different, 2 and 1. From A to B the value is 2 and from B to A the value is 1 because 2 are directing from A to B and one is directed from B to A. So likewise in the urgency matrix for a directed multigraph, Aij equals the number of the edges that are associated to I and J. So same in the formal definition you can say like that. Understood? So these are all about the representation of the graph. So in this lecture we have seen only two methods how to represent a graph. The first one is the urgency list and second one is the urgency matrices. Okay. In the next lecture we will see uh, about the incident matrices. Okay. Thank you.